And you're going to see these kind of functions later on in the semester. So we're going to look at what we call polynomial and rational functions. So I'm going to teach you the characteristics of these things, okay? So first of all, what a polynomial function is you just take sums and differences. You add and subtract, and you do whole number powers of x, okay? So it's kind of helpful to know what a whole number is. A whole number just means you start with 0 and you just start counting on your fingers forever. Okay, that's what a whole number is. It just starts at 0. Okay, so let's write down just 3 examples. I'm just going to give you an example. It's easier to show what a polynomial is sometimes than define it. So let's just write down like f of x. Okay, that's the name of the function. So what you always do when you make a polynomial is you have x and you give it a whole number power. Whatever what it is up to you. And you can put as many of these in as you want. I'm just going to put like something like that. Okay, so just make sure you have powers, whole number powers on x. Then you just add and subtract however you want to. Okay, like that. That's a polynomial. And then you can put any number you want to in front of those x's, or you don't have to. So that would be an example of a polynomial. You're just taking powers of x, adding and subtracting. That's it. You'll learn to recognize when you have a polynomial. Okay, let me give you a second example. Okay, this time let's just put an x in there and let's just put a second power on it. Okay, then let's put an x to the first power, and then let's just put a number like 10. Okay, so you always got to have some power of x in there that's a whole number, and then you can add and subtract however you want, and then you can put whatever number you want to in front of it. So that's another polynomial. Does everybody understand what I'm doing? Just taking x, giving it a power, and then adding and subtracting these powers of x. That's it. Okay, here's one other one. F of x equals something like, let's just say x, and then have a number, put a number in front of x, and then just subtract. So what you're really doing on a polynomial is you just have x's to a power, you add and subtract them. That's it. That's what a polynomial function is, okay? All right? And as you kind of learn the characteristics of these things, you'll start recognizing what they look like pretty easily. Okay, so here's how the graphs go. And I'm going to kind of teach you how these graphs go. This is just stuff. No matter what you graph on a polynomial function, there's always 4 types that you're going to have. Okay, either the graph turns up, kind of goes like this at the ends, or it can turn down, so it can go like that. Or it can go like this. It can turn down and turn up that way, so it's kind of like this. Or it can do the reverse of that. So a polynomial graph kind of does this. It either goes like this at the end, or goes like this at the end, or this and this. Does that make sense? Those are the only possibilities there are, so you're always going to have one of those types of graphs. What happens in the middle, it kind of wiggles and stuff, that doesn't make any difference to us. We just want to know we can do this, 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 or this. Okay, that's what you want to get down. Okay, all right. So what I'm going to do on the next page is I'm going to show you what's called the leading coefficient test. It's a very simple thing to do. It gives you an idea of what the graph is. Those of you who will go on and take like the calculus in the next semester, this stuff shows up and it's kind of nice to know this, because it'll kind of save you some time. All right, so let's see. I'm going to show you the dance moves of the polynomial. So I went on the internet and just found some dancers, okay? So here's the hula dancer. So here's what happens. Okay, if the highest power is odd and the leading coefficient's positive, then the graph looks like this. So what I'm going to do is I'm just going to give you an example to write down. So let's write down this example. Let's say that we have x to the third plus 2x to the second minus 3x plus 5. Okay, that's a polynomial like that. You just add and subtract powers of x. So here's what you're trying to learn on this. The highest power is odd. If the highest power is odd, then it's either going to go like this or it's going to go like that. Okay, that's how your graph's going to go. All right, so it depends on what the number in front of the highest power is. So we call that the leading coefficient. I'll just abbreviate that leading coefficient, so that's positive. Okay, so if that leading coefficient's positive, then here's how you graph. Okay, you just put an arrow there, and that's good enough. Okay, what happens in the middle we don't care about. So the idea is, if your highest power is positive and or if higher power is odd and that's positive, that's what the graph does. It looks like this dancer. Okay, is everybody with me there? Okay, all right. So it's real simple if you go through and do this. Okay, the next one is like this. So here's the disco dancer. It's still odd, but now the leading coefficient's negative. Well, it just changes the direction. Anytime it's odd, the polynomial does one of these things. Okay, did you ever see Saturday Night Fever? Did anybody ever see that movie? That's kind of, you did, all right. Okay, that's way old. I mean, that's like before most of your time. John Travolta was the star. That was his disco move. Okay, so he was doing something kind of like this. So here's, let's write down this example. So let's say we have f of x. Let's have a fifth power. And I'm just creating something. The key thing is if the highest power is odd, then it does that dance move. And then if you have a negative number there, where you have the leading coefficients negative, then it just does the opposite. It goes like this, and it goes like that. Okay? So that's how that goes. All right? So odd function, if the highest power is odd, it's going to look like one of those two. Does that make sense? The y part, you would have to crunch out the numbers on a calculator to get the idea. Yeah?
So you said the leading coefficient becomes negative?
Then it does that other one. Yeah, it's kind of like a reflection. So like if this one would be the number is positive, then it goes like that. But once you change that to a negative, it just does the opposite because it's like a reflection. It just changes the numbers around is what it does. Okay? All right, so that's how that goes. Okay, so that's how odd ones go. Even ones go like this. Okay, so if you have an even, like highest degree is even, the leading coefficient's positive, it's going to go like that, kind of like a parabola opening upward. So let's use this as an example. Let's say we have x to the fourth minus x squared plus 10. It turns out that the only thing that matters is the highest power. That determines everything. And if we put a positive number there, like a leading coefficient that's positive, then it just goes like that. What happens between, it'll probably wiggle, but that's not what we care about right now. So that's what that looks like. Okay? All right? And then on the next page, well, let's see, I got the dancer. It's just the opposite of that. Okay, like that. Okay? So this goes like this. If, let's say that you had f of x, and let's just use x squared, for example. Okay? And if you put a negative number there, well, that's a parabola going down, so that would end up looking like that. Okay? So that's kind of the idea is like this. So if it's odd, what does it do? I always feel like I'm dancing when I teach this. So that's odd. What's even? Or that. Okay? That's the difference. Everybody with me? Okay? All right? Very simple stuff to learn how to do and put together. So what we're going to do is I'll start kind of putting this together now for you, and we'll look at this then. Okay? So first of all, on this first example, this is the polynomial. The degree is the highest power. Okay? So the degree is 3, and that's odd. Okay? So that's going to tell you the graph either does this or it does that. That's all we care about. The leading coefficient is the number in front of the highest power, so that's -1. Okay? So what it means is the power function it resembles is just f of x equals -x to the third. All those numbers past -x to the third don't impact how the graph goes at the endpoints. So this one would be the one that goes like this. So you go like that, and you go like that. Until you get that down, you can look that up. So that's how that endpoint would go. Okay? Now, this next thing, you got to understand what this terminology is saying. So, and those of you who are going to go and take calculus, you'll see this. This just means as x gets bigger, x goes to infinity. That just means x gets bigger. If x gets bigger, what happens to y? It gets smaller, right? Okay, so what you would say is the y would go to -infinity. That's what that says. If you're not familiar with this, you got to understand that terminology. This says is x goes this way. If x gets smaller, what happens to y? Good, it goes to infinity, like that. So that goes to positive infinity like that. So you want to understand how that goes, all right? All right? All right, the next one. What is the degree of the next example? 4, okay, that's even. So we said if it's even, it's either going to turn up or turn down, okay? What's the leading coefficient? Number in front, right? That's 1. That's positive. So that means it's going to turn up like that. Okay? And it just resembles, you just look at the first term, it's going to resemble the power function x to the fourth, like that. Okay? So since it's an even degree polynomial, leading coefficient's positive, then your graph is going to go like this. Okay? We don't care about what happens in the middle. Okay. Now, what this says. This says if x gets big, what happens to y? It gets big also, so that would be infinity. This says if x gets small, what happens to y? It gets big also, so the answer to both of those would be positive infinity, see? Okay, that's the terminology that you're wanting to make sure you have down. Okay, everybody with me there? If you came in late, I got the two handouts up here, so if anybody needs to come up and pick up, there's a 2.4 and a 4.1 if anybody needs to pick it up, okay? Okay, all right, next one. Let's see on this one. The degree is what? 5, so it's odd. The leading coefficient is the number in front of that, so that's 1. So it's positive. So what that one means is if it's odd and the leading coefficient's positive, then it goes like that. Okay, that's one of the other cases. And this is just going to look a lot like the graph of x to the fifth. That's what makes the difference. Okay. All right, what would this be? X gets big, what happens to y? X gets big, where does y go? It gets big. That's infinity. How about this one? X gets small, where does y go? Negative infinity. Okay, that's what that means. You want to understand that terminology. X gets big, y gets big. X gets small, y gets small. Like that. That's the idea. Okay? All right, and then the next one, just giving you one of each. The degree would be 2. Leading coefficient is -1. So that would be a parabola that's going downward. Okay, so this one is going to go like this. And then that's going to be the same, essentially, as f of x equals -x squared. That's what makes the difference. Okay, so what is this one going to be? If x gets big, what happens to y? It's down. Okay, how about this one? X gets small, what happens to y? Down, negative infinity. Okay, so it's going to go like this. Both of those are going to go to negative infinity like that. Okay? Is everybody with me okay?
Why is the degree 2?
Say that again.
Why is on that one the degree 2?
It's all, the degree is always the highest exponent.
Oh, okay.
Okay? Yeah, so it's always whatever the highest exponent on x is you find gives you the degree. And it's either odd or even. Okay? Your exponents are always whole numbers. Okay? Okay, so this is just kind of a summary of these two. This is what the even degree looks like. So like this or this. That's what the odd degree looks like that. Okay, so once you kind of get that in your mind, then it's pretty easy to get a rough idea what the graphs look like. Okay. Okay, on the next page, what I want you to do is just fill in, just take a minute, it doesn't take very long. I want you to just tell me, look at the graph I gave you, tell me if it's odd or even, tell me if the leading coefficient's plus or minus. And you can look back at that previous table if you need to. But until you get it figured out, you want to get this real quick. Odd is like John Travolta. The other one's like parabolas. Even's like parabolas. That's the way I think of it, okay? I just got to know which one is on the leading coefficient.
Do we do C?
And then C, let's not worry about C. I just want you to do these 4 problems, and then we start kind of looking at a few other ideas here. Okay, let me ask you this way. Which two of these problems, which 2 problems are going to be even?
4.
2 and 4, right? These are the 2 that are going to be even. Okay, so those are even. Which one is positive leading coefficient, 2 or 4? 4, okay, so that's positive. That's negative like that, okay? Then the other ones are odd, so that's odd, and it goes like this. Positive will go like this. If it's a positive leading coefficient, it just means as you go to the right, it goes up. And then if it's a negative leading coefficient, it's going to go like that. Okay, everybody got that okay? Okay, that's pretty simple. All right, next thing we're going to look at is X-Intercepts. So we've been talking about this already, so we're going to work with finding intercepts throughout the semester. So an x-intercept's a point on the x-axis when y is 0. Okay, so we're going to just come up with 3 examples of x-intercepts. One example would be 3, 0. Okay, x is some number, y is 0. So you can just kind of randomly come up with whatever you want to, but the y value has to be 0. Okay, just put any number in you want. Okay, so that would be what x-intercepts look like. Okay, on a y-intercept, what happens is x is 0. So it's just the opposite thing. So for a y-intercept, you would have x being 0, and then y could be anything. Y could even be 0. So I'll just put a couple of numbers in there like that. Okay, that's what they look like. So the methodology of finding intercepts, you will remember it if you remember the opposite variable 0, and then you have the ability to figure it out okay. Now, we've already been working on that a little bit, okay? All right, so this diagram on this next page shows that. This would be an example of a y-intercept. That's an example of an x-intercept, okay? Now, what we're going to do is we're going to crunch out some of these things algebraically. You have to know how to do factoring pretty good to do this, and then for a y-intercept, you just got to do arithmetic. Okay, so the first thing on this one is, what kind of equation is 3x minus 9? What do we call that? What kind of function is that? It's linear, right? Okay. What's the highest exponent? There's not an exponent on x, so what does it have to be? It has to be 1, right? So that degree is 1. That's the highest power there, okay? So what you do when you do an x-intercept is you just set f of x equals 0. So the f of x becomes 0, and then you want to solve that equation. Okay, so one of the reasons we started solving equations in this class is so you can do stuff like this. Okay, so now it's pretty easy to do. You can add 9 to both sides. Okay, that's going to give 9 is equal to 3x. Then you can divide by 3. So we get x is equal to 3. So your x-intercept is 3. And you want to write that as the point 3, 0. Okay, so again, anytime you find an x-intercept, it's always the same. Let the function be 0, solve the equation. That's always the same. Everybody with me there? Okay. All right. Okay. Now, when you do a y-intercept, what you do is you set x equal to 0. Okay, so we just go to the function, and we're just going to replace that x with 0, so we'd have 3 times 0 minus 9. So what is that? Minus 9, right? 0 minus 9 is negative 9. So that means your y-intercept would be 0, negative 9. Okay? So notice the x-intercept has a y value of 0, whereas the y-intercept has an x value of 0. It's always the same, no matter what the function is. Okay? All right, part B. What do you do to find the x-intercept? Which thing goes to 0, the function or x? Which one? Do I do g of x equals 0 or x equals 0? Is there anybody out there? Is there anybody? You don't even know what I'm saying. Pink Floyd? You like Pink Floyd? They have a song. Is there anybody out there? Off the wall. Okay, so that's how you do that. Okay, we'll do that. All right. Now we got to factor that. Some of you are kind of weak in your factoring. This is called a difference of two squares. Okay, which we've encountered before. So you draw 2 parentheses. You say x times x to get x squared. You say 5 times 5 to get 25. Then you put plus and minus. So we have done that before, right? Okay. Now the rest of it you can do in your head. You take each factor and you set it equal to 0. Okay. Okay if you do that in your head. This would just be x equals negative 5. That would be x equals 5. Okay, like that. Now, see, you can do this in your head. You really can. What happens if you take 5 squared minus 25? Don't you get 0 if you do 5 to the second minus 25? So that's why it's an x-intercept. Okay, that's what's making the function 0. So your degree is 2. Your intercepts would then be the point negative 5, 0 and the point 5, 0 like that. Those would be the 2 places where it crosses the x-axis. Okay. All right, y-intercept's always a lot easier for students. You just set x equals 0. Most of the time you can do this in your head. So just go to the function, 0 squared minus 25. So what is that? That's negative 25. So you would have the point 0, negative 25 like that. Okay? So same methodology. It's always the same. Okay, everybody with me? Now I'm doing several examples because a lot of you need to work on factoring and get it down. Okay, the next one you have a degree of 2. So the x-intercept, you're going to do x squared minus 6x minus 27 equals 0. Yeah.
Just clarifying, it's the degree of 2 because it's x squared. So
that's the highest exponent in the problem, right? Degree is always the highest power. Most of these things are going to be second powers on these things, okay? All right, so let's see if we can get the factoring down on this. So it goes like this. All right, so you'd have x and x. What would you use for 27? You got to find two numbers that multiply to give 27, and at the same time they got to add up to negative 6. 9 and 3, right? 9 times 3 is 27, so that's correct. Now, how do you make 9 and 3 add up to negative 6? Negative 9 plus 3. There you go. Good. Okay. So you got that. So the intercepts are what in your head? I want you to do it in your head from here on out. What do you have? 9 and negative 3, right? Okay. So your first intercept would be 9, 0. The second one would be negative 3, 0. Because you're just setting each factor to 0. You're solving those two equations. Okay. Y-intercept, most of the time on the y-intercepts, you'll do these in your head. Set x equals 0, you would do 0 squared minus 6 times 0 minus 27. So what is that? Negative 27. As I said, you can do those in your head. So the y-intercept would go 0, negative 27 like that. Okay, that's it. Okay? All right? Now, I tried to give you an example of each type of factoring. The next factoring is the one that students do don't do the best on. So that's a degree of 2. So again, on your x-intercept, we're going to do 10x squared plus 19x minus 15 equals 0. Now, you want to try to factor this and see what happens. So generally, what you want to do on this is kind of a trial and error thing. So we're going to draw two parentheses. Watch this carefully because a lot of times students just don't do this very good. For the first term, you have two choices. You can do 2x and x, 10 times 1, or you can do 5 times 2. And you just have to try one of them, okay? For the last term, the 15, you can go 1 and 15, or you can go 3 and 5, okay? What I usually tell students to do is just pick the ones close together. So don't do 10 and 1, do 5 and 2 because they're closer together. And you can't do this in your head, so you just put 5x and 2x like that. Okay, just put it down, write it on your paper. And then do the 3 and 5, okay? Now, the order you do it in will make a difference, so I'm going to start that way. Okay, so I got 5 and 2, 3 and 5. Now, to know whether you're doing this right or not, it all depends on whether you can make that come together to give a 19. So this inner term is 6x. The outer term, 5 times 5, is 25x. So, is there any way to make 25 and 6 add up to 19? There you go, good. See, if you write it on your paper, then you can see it. Now, if it doesn't work, then you got to try something else. So that means that the 3 has to be negative so you can get a negative 6x, and the 5 has to be positive so you can get a positive 5. Okay? Just try things on that. You got to try until you find the combination. So now what you do, and you're going to solve these two equations. You have 5x minus 3 equals 0. Then you have 2x plus 5 equals 0 like that. So those two equations you can solve. These are basic equations. You can add 3 to both sides to get that. Divide by 5. So you're going to get 3/5. So one of your x-intercepts is a fraction, which is okay. So we just say 3/5 comma 0. That's your first one. That's where it crosses the x-axis. Second one, again, you can subtract 5 from both sides and then divide by 2, so you would get negative 5/2. So the hardest part of that problem is the factoring, okay? And most all these problems, this is where you're going to factor. Anytime you find intercepts, that's what you try to do. Now let me ask this question, because I want you to do this in your head. Can you tell me what the y-intercept is in your head? Yeah, because all you do on the next one's let all the x's go to 0, and if that goes to 0 and that goes to 0, you're there. Okay, so you can do that in your head. The factoring stuff's a little bit harder to do, so you can just write down you have 10 times 0 squared plus 19 times 0 minus 15, so you would have the point 0, negative 15. Okay? And don't forget, the opposite variable goes to 0 when you're doing intercepts, okay? The algebra is the big deal in this problem for most students.
Saying the X-Intercepts, I think it was 3/5 0
Yep. Yeah, this one's 3/5 0 because I solved this I solved the equation 5x minus 3 equals 0. The other one was solving the equation 2x plus 5 equals 0. So once you get your factors, you got to set them to 0 and solve those equations. Okay? All right. So factoring's the big deal. Okay? I'm going to do two other things here. And with this one, they're already factored. So actually finding the intercepts is easier on these problems. The degree is a little tricky on this, but really all you're doing, you don't have to multiply this out. What you want to think about is just look at this number and that number, and look at that number and that number like there. Okay, this is how I figure out the degree. So really, if you have 2x to the second, don't pay attention to the 7, it doesn't make any difference. Here, don't pay any attention to the 8, it doesn't matter. So we just do this. Okay, so if you multiplied that out, what you would have is, if you did 2x times 2x, you would have 4x to the second times x to the third. So what is 4x to the second times x to the third? Is it x to the fifth or is it x to the sixth? X to the fifth. Okay, right? Okay. So you add the exponents on that, so that's 4x to the fifth. Okay. That means the degree on that's 5. You don't have to multiply it out, you just got to reason it out. Okay. All right. Now the x-intercepts, what you want to do on the x-intercept is it's already factored. See how we already have two parentheses? So what you do is you just do this. You don't have to factor it. I've already factored it for you. So you solve that equation, and then you solve that equation, and then that'll give you your two x-intercepts. Okay, like that. Okay, most of this you can do in your head. That's 2x equals 7. Then you divide by 2, so you're going to get 7 halves. Okay, so your first intercept is 7 halves 0. And then what's the second one in your head? X minus 8 is 0. What's x? 8. There you go. Okay, anytime you do it in your head, just do it in your head. So your other one is 8, 0. Okay. Now the y-intercept is just arithmetic, and you can learn to do it in your head, but what I'm going to do is just write out on the y-intercept, again, we said x equals 0. And if you did that, you would have 2 times 0 minus 7 to the second. And then the second parenthesis, you'd have 0 minus 8 to the second like that. Now just do the arithmetic. This would end up being negative 7 to the second. This would be negative 8 to the second. And this is going to be big numbers, so you'd probably want to take your calculator. Negative 7 to the second, I think, is 49. Yep. What? Oh, that's a 3, isn't it? Okay, I didn't see the 3. Okay, now I do. Thank you. Okay, yeah, we're going to get like a real big number. You got to use a calculator on this. So if I go negative 8 to the third, I'm going to get on this, I'm going to get negative 512. Okay, like that. Okay, and then I can just take my calculator and take 512 times 49, which gives me this big number. So the y-intercept is 0, negative 25,088. Okay, you can't really do that one in your head. You know, the numbers are too big. But you can have an intercept with a real big number on it, like that. So that's the idea. Okay? All right. That's a little harder to do that problem. There's a little bit more involved in it, except the x-intercept on these is going to be easier. All right? So the next one, when you do the degree on the next one, again, what matters is this and that exponent, this and that. Okay, these things make no difference in figuring out the degree, because what you're trying to do is find the highest power of x. So what I'm going to do is I'm just going to think about 4x squared times x to the third to the fourth. That's all that matters. Okay, and if I can do that algebra problem correctly, whatever that power is the degree. Okay, what happens if you do 4x squared and multiply it by itself? What do you get? 16x to the fourth. Thank you. Okay, so we got 16x to the fourth. Okay, how about if you do x to the third to the fourth? That means x to the third is multiplied out 4 times. What do the exponents total up to? 12.
7 times 3.
Yeah, you can just do 3 times 4 as a shortcut. So that would just be x to the 12th like that.
Well, why wouldn't it be 3 times 3?
No, what you're doing is if you do it this way, you're adding. You're totaling what those powers are, 3, 6, 9, 12. Okay, the shortcut on that's just to multiply. Okay, so what is this? That's 16x to what power? 16. Totaling. When you're multiplying, you're totaling what the exponents are. So that means the degree on that is 16. Okay, you know what would happen? If you put it in the graphing calculator, the graph's going to go like this. Okay, it's an even degree polynomial, so that's what would end up happening. Okay, now next thing we want to do is we want to take what's in the parentheses and set it equal to 0. Like that. So we got to solve those two equations. Okay, and we're going to get more than 2 intercepts on this time. Okay, the degree sometimes is kind of tricky for students, but you just kind of look at the numbers that I highlighted in yellow. That's how you figure out that degree. Okay, let's look at this. How would you solve this equation? You got to factor. Can you factor 4x squared minus 9? I want you to be fast on this. How do the 2 parentheses go? Come on, say something. Got to get you guys on track here. What and what gives 4x squared? 2x, 2x. Okay, if you're wrong, I'm not going to laugh at you. How about for the 9? 3 and 3. How do the signs go? There you go, plus minus. You want to get to a point when you see a difference of 2 squares factoring, you can do that fast and efficiently. Now what you do is you solve this equation, and then you solve this equation. Okay, like that. Okay, so these are easy equations to do. You subtract 3 from both sides, or just move the 3, divide by 2. That's going to give you negative 3 halves. So your first intercept's negative 3 halves, comma 0. Okay, the next one, you can move the 3 over there. That's 2x equals 3. Divide by 2, you're going to get x equals positive 3 halves. Okay, so you're going to get a second intercept as 3 halves, 0 like that. Okay, so it's all the factoring. That's what I've been working on here for the last several minutes. It's kind of doing these equations with factoring. Okay, the next one, depends on your guys' background on this one. I don't know. This one does factor, but we're not going to touch how to do the factoring and finite math on this one. What we're going to do instead on this one is you could try to just do this in your head, and I'll show you how to do that in just a minute. So I'm going to move the negative 1 like that. Now, when you have that, you got to make the third power just become x. So what you do is you do a third root of both sides. Now, we've looked at this a couple of times earlier on the semester. When you do a third root of something to the third, it undoes the operation. And then the third root of negative 1, well, tell me a number that you multiply out 3 times that would give you negative 1. There is such a number. What is it? Negative 1, exactly. So that would be another intercept would be negative 1, 0. Okay, like that. Now, if you were in doubt on this and you had no clue how to get those intercepts, your graphing calculator would bail you out of this. Okay? So I want you to just watch this. You don't have to put this in your calculator. But when these problems get a little bit more advanced, hey, you can graph them. So I'm just going to put in like 4x squared minus 9, close parentheses, and square it, like that. And then I'm going to put in the next parenthesis, which is x to the third, and then plus 1, and to the 4th power. Tell me if I got this in right. Sometimes I can't see on there. I think that looks good. All right. Does that look good? Okay. Now check this out. Okay, I'm just going to go zoom 6. I'm going to do this in a standard window. Zoom 6. The graph is going to go like this because it's an even degree polynomial. Now, if I zoom in on this a little bit, there's always a button on here that goes like this, zoom in, and that just kind of zooms in on a little piece of that like this. So now if you look at this, you can kind of look at what these intercepts are. So one of them was negative 1. You can see that one right there. The other one was 3 halves, which is not showing up for some reason. I don't know why. Let me make sure I got everything in here right. Let me go back and do this one more time. So let me show you what you can do. Okay, so if you trace at these intercepts, if you trace at -1, okay, you can tell that's an X-intercept, right? It's blinking on the X-axis. If I trace at 3/2, like that, it's blinking on there too. The graph is weird on this when it's just not showing up, but as an intercept. And then if I trace at -3/2, same thing's going to happen. See how it blinks on an intercept? So you can tell you're right, okay, when you do these things. You want to learn to use your calculator to verify things. When they get a little bit more complicated, take that approach, okay? Okay, so that's what I'm going to show you about polynomials. The last thing I want to do on this is finish up the Y-intercept. So when we do the Y-intercept, we're going to replace all of the x's with 0, and then just crunch this out, okay? Use your calculator if you need to. So see, this is going to go to 0. So that's -9 to the second. That's going to go to 1. So you have -9 to the second times 1 to the fourth. That will be 81 times 1. So therefore that's 81. So your Y-intercept is going to be 0.81 like that. Okay? The last two examples I did are the ones that are the harder ones for somebody at this level of a class. There's a little bit more going on that. Okay. So to summarize real quick, basically what we've done. Okay, if you have an even degree polynomial, what are the two possibilities for the graph? This and this. Everybody got that? If it's an odd degree polynomial, what are the two possibilities? This and this. Okay, that's what we learned. That's the first thing. Second thing is, how do you find an X-intercept? You set the function equal to 0 and solve the equation. A lot of times by factoring. How do you find a Y-intercept? You set x equal to 0. Those are really the things that we've talked about so far. Okay, that's about the extent that we learn in Finite about polynomial functions. Okay, so the next thing I'm going to do is we're going to look at rational functions, and a lot of the graphing on this section you're going to do with your calculator. Okay, you'll be allowed to use your calculator. So what a rational function is you take polynomials and put them in a fraction. Okay, we've already seen some of these before. Let me give you 3 examples to write down. Okay, so first of all, you just put a polynomial in the denominator. That's a polynomial. Okay, like that. Put a polynomial in the numerator. That would be a rational function. So it's just a ratio of polynomials. Okay, and they can look all kinds of different ways. And another example would just, you could have a 1 in the numerator. Just a number by itself is still a polynomial. Okay, and then you could have whatever you wanted in the bottom as long as it's polynomial. So you're dealing with fractions. Okay, a third possibility, I'll just have something like x to the third minus 1, x to the second plus x plus 2. Okay, that's what rational functions look like, is they're fractions, and the numerator and denominator are polynomials. That's all they are. Okay. So what we're going to look at is we're going to kind of begin to look at how these things graph. You're going to see this a lot from time to time in applications. Those of you that go on and take the calculus class after this, it's really helpful to learn this stuff good when you're in this class, because a lot of times when I teach calculus, students don't know this very well, so I have to go through and reteach it and everything. So first thing is what will happen on this is we have what we call a vertical asymptote, and what that is that's just a place where the denominator is 0. A lot of times you can do this in your head. So, in your head, can you tell me what you would plug in for x that would make the bottom 0, just in your head? That'd be a 1, right? Okay. So what you do, anytime you want to find a vertical asymptote, and we'll talk about what that is in a minute. We're not ready to do that yet. You just solve that equation. If you can do it in your head, do it in your head. So add 1 to both sides. That's going to give x equals 1. Okay, like that. Now, why don't you get your calculator out? Those of you who have your calculator with you, go ahead and just get that out, because we're going to do a lot of these graphs of rational functions on our calculator. Okay? So the way you would put this in is like this. You would go to your y equals button, and then you would just go 1 divided by, and then the x minus 1 absolutely has to be in parentheses. A good rule of thumb is to make sure the numerator and denominator are in their own set of parentheses. Okay, you have to do that. Yeah.
How did you get to that screen on the...
Okay, y equals. And you may have something in there. Do you have something in there when you go to y equals? Okay, you there?
I just had to find the button. 1.
Yeah, okay, that's fine. So that's where you put the function in, okay? So 1 over x minus 1. Now just go to zoom 6. So just press zoom
Sorry, how do you do 1 over x?
like this. Make sure you have it in parentheses. The x button's right here. You see what I'm pointing on right here? That's where the variable is. So anytime you press that button, an x should come out, okay? All right, now go to your zoom button and then go number 6. And that's where you just do a standard graph, zoom 6, okay? So what I want to do is just kind of show you what this graph looks like. So what happens when x is equal to 1 is there's a big break in the graph. We call that an asymptote. What will happen anytime you have a vertical asymptote, the graph is either going to go there or it's going to go there, but it won't touch that, okay? If you go to your table of values, like if I go second graph to the table of values, I want to show you what happens. See, when x is 1, you have an error. Okay, we're undefined when x is 1. So rational functions, the graphs are going to kind of look like that. They'll have breaks in them wherever that denominator is 0. Okay, so that's how you would do that. Is everybody okay with the calculator? Anything? Go ahead.
So there's 1.
Yeah, you want to just go.
By parentheses x, is that?
Yeah, you got to put that in parentheses. So you should have like your parenthesis keys, and then your x key is right here. That one that's right next to alpha, that's where you put the x in. Okay, that's how that goes. Okay, so that's how you would do that. Everybody following along okay? Okay.
And look, you hit graph to have it follow on.
Yep.
Right?
And what I did was I did this. If you've got everything in, one of the simplest ways to do a graph that puts the window standard is go zoom, press your zoom button at the top, and then go down to 6, zoom standard, number 6, that'll put it in a standard window. Okay, it goes like that. Okay. All right, so we'll kind of get with the graphing on that as we go through this. We're going to go to the next page and we'll focus a little bit on the asymptotes here for a few minutes. Okay, so what you do on the next one is we want to look at the denominator and figure out what makes it 0. Okay, you can't do this one in your head. So what we want to do is we want to go ahead and factor that denominator. Okay, so I'll do this at the side. We have x squared plus 4x minus 12. Okay, let's go ahead and let's think about how the factoring goes. So the first term is going to be x and x, right? Okay, last term. What are your possibilities? 1 times 12, 2 times 6, 3 times 4. What's the right one? Because they got to add up to 4. What do you multiply to give 12 that adds up to 4? 6 and 2, right. 6 times 2 is 12. 6 and 2 can add up to 4. So I put in a 2 and 6 there. Okay. How do I make 6 and 2 add up to positive 4? What signs? How do the signs go? Minus 2 plus 6. Good. Okay, that's it. All right. So what you would have is you would have x minus 2. Then you'd have x plus 6 like that. That's the factoring that goes on. Now, what you want to do, and you can do this in your head, what would make this factor 0? Just that in your head. What would make that 0? 2. What would make that 0? Negative 6, right? So you can do that in your head, or you can just write it down and solve the equation. So you got to solve that equation, and then you got to solve this equation. Okay, so that would be add 2 to both sides, you'd have x equals 2. Subtract 6 from both sides, you'd have x equals negative 6. So your vertical asymptotes are 2 and negative 6. Now I'm not going to take the time to graph that on the calculator, but if you did, you'd kind of have a break in the graph at negative 2 and 1 at, or 1 at 2 and 1 at negative 6, and you would have kind of a similar graph to what I just did. So when you're doing a vertical asymptote, you want to focus just on the denominator and what makes it 0. So you have to factor. If you can't factor, you can't do this. Okay, that's as simple as it is. Okay, next thing on this one, we're going to look at g of x is equal to x plus 4. And how do you factor x squared minus 16? I want you to be fast. What do? X and x, 4 and 4, plus and minus. Okay, good. That is the difference of 2 squares. The more with this stuff you do, the faster you're going to get. Okay, so what I have is I have x plus 4 over x plus 4 times x minus 4. So what happens is the x plus 4's cross out, don't they? Okay, so that means you're left with 1 over x minus 4. So now all you got to do is look at what makes that 0. So what makes x minus 4 equal a 0? 4, okay? So x equals 4. That's your only vertical asymptote on that would be x equals 4. So don't forget to cancel. If one of those cancels out, that's not going to be an asymptote anymore. Okay, that's the idea. Okay? All right. So let's do one thing with the calculator. And I'll kind of use this next example 4. We'll do example 4, then we'll take a break. So I want to kind of use this to help you understand how these graphs go. All right. So first of all, this is a problem I want you to be able to do in your head. Okay, what would make the denominator 0 in your head? 2, okay? All right, so that means your vertical asymptote is x equals 2. Okay, now we're going to do a graph on this, but we're going to use our calculator to help us a little bit with this. So on the graph I gave you, go ahead and put a vertical line that goes through x equals 2. Okay, the vertical asymptote's just a vertical line that goes through that x value. Okay, now we're going to do this one on the calculator. And I'll kind of show you how this, we're going to fill this table out. So what you want to do is you want to go to y equals, put it in, 1 divided by parentheses and then x minus 2. Like that. So you want to get that put in. And then close parentheses. All right. Now, what we're going to do is I want you to reset your window. So I want to make sure everybody knows how to reset a window. So once you got that put in, press your window button. Now what you're going to do is you're going to make the x go from -8 to 8. You're going to make the y's go from -8 to 8 also. So you type this in like this. Press window, x minimum, put in a -8. Be sure you use your negative button to do that. Okay. X max, put in an 8. X scale just means what do you want the x to go by. We want x probably to go by 1. So I'm just going to put a 1 there. For y's, it's the same thing. We're going down to -8. And we're going up to 8 by a scale of 1 like that. Okay, so that's what you do on the window. You have to set the x-axis when you do this then. Okay, now press graph and then we'll have our graph. Okay, now what will happen is you're going to see that break in the graph. The graphing calculator usually doesn't show the asymptote. It does with some of the models, so it does that. Yeah.
What was the y scale and x resolution?
The y scale is just like what each of these notches are. So I'm just going to...
What did you...
Don't worry about the resolution. Leave that alone. So just do what you want to get done is you want to get that put in and that put in right there. Everything else, just leave it alone. -8 to 8 in both directions is what we're doing. Okay? Okay, now what we're going to do is we're going to fill in this chart. So you have to have the graph on your graphing calculator to get this done. Okay? So what you want to do once it's in, you want to type trace. So once you've got the graph in, just type trace and then put in 1.9. Okay? Now if it's not working for you, just see me at break or after class. So what I'm going to have is when x is 1.9, y is going to be -10. So we're just going to fill this out together. Okay? Do it again. Trace. Now do 1.99 and see what we get. That's -100. Okay? Do it again. We're going to trace at 1.999, not 3 nines. That's going to be -1,000. Okay, like that. And then to keep doing that, trace it to. Trace it to, what happens? You get an error. Okay, you're undefined there. That's because you have the vertical asymptote like that. Okay, keep doing it. Now let's go to 2.1. Doesn't matter what order you put that in. That's 10. 2.01 is 100. And 2.001 is probably going to be 1,000. Okay, now if that's not working for you, just see me after class because you got to get everything in your graph and learn how to use that trace button. So this is basically what I'm wanting you to get out of this, is this. Okay, the idea is if you're real close to 2 on the left side, what's happening to the graph? It's going down this way. So when you're below 2, those are negative numbers, right? When you're to the right of 2, what kind of numbers are here? Big numbers. So it kind of goes like this. And I want you to just see this chart so you get an understanding of how that goes. So your graph's going to kind of go like this. As you get barely above 2, the graph goes like this. And then it just kind of levels off, so you can just sketch the rest like that. And then if you're a little bit to the left of 2, then you're going down into the negative numbers like that. Okay, so that's a good enough sketch for what we're doing there. Okay, but the way to understand how asymptotes work is to crunch out what I just did. The closer you get to 2, what happens? The bigger that number gets or the smaller. Does that make sense? So if you got a vertical asymptote, the graph's going to go there or it's going to go there. It ain't going to do anything else. That's always going to happen. Everybody with me there? That's because of that, what that arithmetic does. Okay, that's how everything works out. Okay, so let's go ahead and let's take a break here, and for about 10 minutes, come back, and then we're going to finish this up. Most of the graphing we're going to do in this section is going to be done with a calculator. Now, if you got any trouble with your calculator, you can come up right now if you want to, and I'll help you. On this next page, this is just kind of a summary of what we're going to do with asymptotes. So the next thing I want to go through is how to find a horizontal asymptote. Okay, now I've shown you how to do a vertical asymptote, and that's an important thing to do, is you just set the denominator equal to 0 primarily. That's what we got through doing. All right, so a horizontal asymptote is totally different. I'm just going to teach you the shortcut rules in this level of a class. So I'm going to go through these 3 rules. I'm not going to read those to you. That's for you to refer to just as a reminder. So let's go straight down to this example 5, and I'll show you kind of how we're going to begin to put all this together. Okay. First thing is the degree of the numerator is the highest power of x, so that's a 1. The degree of the denominator is the highest power of x, so that's a 1. Okay. So here's what rule number 1 says. So, and you don't have to write this down. I just want to write down what I'm saying. If the degree of the numerator is equal to the degree of the denominator, okay, then it turns out that all you got to do is look at this part of the problem right here. You just look at 2x over x, and it turns out that the answer to the horizontal asymptote is just the ratio of 2 over 1. And a horizontal asymptote is y equals a number. Remember, y equals a number is going horizontally like that. So the horizontal asymptote is y equals 2. All right. Another example of that would be, and you don't have to write this down, if you had 3x squared minus x over 4x squared plus x plus 2. Since the degrees are the same, the horizontal asymptote is y equals 3/4. And I'll explain what that is in just a minute. So you look at the degrees and see if they're the same or not, and that's how you determine that. Okay, so what I'm going to have you do is go ahead this time and go make a horizontal line and make that go through y equals 2 like that. Okay, we haven't talked about horizontal asymptotes, so I'll talk about what those things do next here. Okay, now we're going to go ahead and find the vertical asymptote. So when you do the vertical asymptote, that's what we did before break. Remember I said take the denominator and set that equal to 0. Okay, solve that equation. What's the vertical asymptote? X equals 1, right? Okay, so what you would have is you would have a vertical asymptote at x equals 1. Okay, so you need to go to the graph that I gave you and put a vertical line through 1 like that. Okay, so this is the vertical asymptote. The other one is the horizontal asymptote like that. All right. Now, for these kind of problems, for this particular class, and since it's finite and not college algebra, I'm going to have you do these on the calculator, and I'll kind of use that to teach you why the graphs go the way they do. So let's go ahead and get your calculator out and do these with me. And you want to make sure you know how to put these in your calculator. One thing that you have to do on this problem, when you go to y1, be sure that the numerator is in parentheses, because if it isn't, you're going to graph it right. And also be sure that the denominator is in parentheses. So go ahead and go to y1 and get everything put in. So we'll have 2x plus 6, close parentheses, divide by, and then left parenthesis, x minus 1 like that. Okay, so you got to graph it like that. And we're going to do this just probably in the same window that we did on the last problem. So if you need to double check your window, just press your window button, and I want you to just match the graph -8 to 8, -8 to 8 like that. Okay, so if you got everything set up and got your window okay, then you just press graph. And then we're going to just kind of use our table of values to get some points on this. So basically what happens is this. This is the first thing I want you to understand. What a horizontal asymptote does is that if this graph goes forever this way, see how it's leveling off? You see what I mean? Okay, so this thing is going to kind of level off underneath like that. And then if x gets big, that also levels off like that. Okay, so what I want you to do to start with on your graphing calculator is just kind of draw something like this. Just make that get close to the asymptote, but it doesn't touch the asymptote. And then this one comes from underneath and just gets closer like that. It'll never touch it. You never touch asymptotes. Okay, it doesn't happen. All right? Then the other thing is, if you're close to the vertical asymptote, remember I said vertical asymptote, what does the graph do? It either does that or it does that. And the graphing calculator is going to tell you which is which. So as you get close to the vertical asymptote, just kind of put a marker like that. And if you're a little bit to the left of it, do like that. Okay? Now, what I would want you to do from here is just get some good points. So one of the easiest ways to get good points is to look at your table of values. So I'm going to go second graph to open up a table of values, and then just start looking for some good points. I mean, by good points, I mean whole numbers. Like there's a point -3, 0. So let's put a dot on there like that. Here's a point -1, -2. So that's a good point. Here's a point 0, -6. And here's a point 3, 6. And there's a point 5, 4. So I would just say get as many points as you can. I'm just looking at my table of values and plotting those points. And then you can sketch in the graph, just kind of connect all those dots, and then it's going to go like that. All right, but you got to make sure that you understand the graph. The horizontal asymptote just means it levels off. The vertical asymptote, it goes to infinity or it goes to -infinity. Does that make sense? You want to get that in your mind. That's what a horizontal asymptote is it tells you how the graph levels off as you get infinitely big or infinitely small. Okay, the table. Everybody with me on how I do the table? Okay, because you want to make an accurate graph. You don't want to just throw in like some shape. You want to get accurate points. Now you've got a perfect graph, say. Okay, all right. So that's how you want to do your asymptotes on that. That's the primary thing we're going to learn how to do. Okay, any questions about what I did? I don't expect you guys to do these graphs any other way except the calculator on these kind of problems. Okay. All right, let's go to this next example. And what happens on this is the degree of the numerator. So look at the numerator. The highest power of x is what? 1. How about the degree of the denominator? What's that? 2. Okay? So you got to know what I mean by a degree. So here's what we have. And you don't need to write this down, but this is what you're going to go through. If the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is going to be y equals 0. Okay, so there's a kind of a quick set of rules that you can learn on this. Anytime that happens, then y equals 0 is the horizontal asymptote. That's totally different than the last example. So what I'll have you do is y equals 0 is just the x-axis. So you're going to make a horizontal line that goes through like that. Okay, that's how you do that. All right, degree of top less than degree of bottom, it's always the same. Okay, now let's look at the vertical asymptote. Okay, what do you look at when you find a vertical asymptote? Which part of the fraction? Bottom. You see what makes it 0, right? So you're going to look at that thing right there. You can do that in your head if you want to. You need to just solve that equation, and that'll tell you what the vertical asymptotes are. Okay, well, you can factor this. X plus 2, x minus 2 equals 0. So that would give x equals -2 and x equals 2. Okay, so we've done that same factoring problem several times today. So what you want to do is go to the graph that I gave you and draw a vertical line through 2, and then draw a vertical line through -2. Like that, and then the rest of this we're going to look at the calculator. Okay, so that's what I want you to be able to do, is identify the asymptotes, then use your calculator to get the accuracy. Okay, all right, so let's go ahead and let's put this one in. And with this one, you want to just put the original form in. Since the numerator just has one thing, you don't have to have it in parentheses. But the denominator, you have to have it in parentheses or it won't graph the right thing. So we just put that in like that. Okay, and always make sure you got those parentheses right. That's what I see students do wrong on this all the time. Okay, now you can just type graph because we've already got the same window on this. And then you'll kind of see what I'm trying to show you, how these asymptotes work. So what's happening is when you're way out here, you're approaching the horizontal asymptote from underneath. Okay, then you're going to -infinity around the vertical asymptote. So it's kind of going to do something like this. And then it's going to approach like that. It's going to go through 0, 0, approach like that. And then the other thing is to the right of this asymptote, it goes to infinity. And as you go way out like this, it goes like that. So I want you to understand vertical asymptote, it does this or this. Everybody got that? Horizontal asymptote, it levels off. Okay, that's the difference between the two. Now what we do is just do your table of values and find some points. Okay, just whatever. So second graph, start looking for points. You can use the ones with decimals. I usually just say find the ones that are good. There's 0, 0. It looks like everything else is a decimal. So from here, you can just go through and sketch it. So what we'll do is just kind of sketch in the shape like this. So that graph did something kind of like that. And then just kind of sketch what's got coming out of the calculator. So it'll go like that, and that's good enough. Okay, you can plot some of the decimal points if you want to, but that's a good indicator of what we have. Okay, so that's the idea. Is everybody following what I'm doing on the calculator? Okay. Because that's how I want you to graph these. Or I don't teach how you do this by hand is in this particular class. All right, asymptotes. So again, just to kind of summarize what we did so far, on the first example, the degree of the top and bottom were the same. So that means the horizontal asymptote's 2 over 1. That happens when they're the same. The problem I just did is the degree of top was smaller than the degree of bottom, so y equals 0 is automatically that asymptote. Those are the first two rules that you learn, okay? Okay, let's go to the next one. So tell me what the degree of the top is on example 7. How about the bottom? Okay, so the degree of top, this is like the last problem, degree of top is less than degree of bottom. What does that tell you? Y equals 0. Okay, so that's your horizontal asymptote. So you don't have to calculate that out, you just got to know that rule. So you go ahead and just do your dashed line through the x-axis like that. Okay, and all that's going to mean when we do this graphing calculator, as we go this way, the graph's going to level off. If we go that way, the graph's going to level off. That's all that means. Okay, now what we want to do is we want to go ahead and do the vertical asymptotes. And this is, you got to be really careful on this one. Okay, so first of all, we're going to factor a 3 out of the top. You want to go ahead and factor both numerator and denominator. So if you factor a 3 out of the top, you'll have that. Okay. Then we also want to factor the denominator, which is a trinomial. So we'll have x and x. You'll have 2 times 1 to get 2. And then to get that minus x there, you'll have a minus and a plus like that. So that would be how you do the factoring. Don't forget about common factors. What do you see happening on that problem? After I factor, what happens? Something cancels, right? So you want to make a note to yourself on this, and I want to mention this. What will happen is this one that cancels out, that's going to give like a hole in the graph. I'll explain what I mean by that in a minute. And the one that's left over is going to give a vertical asymptote. Now we'll see that on the graphing calculator in a minute. Yeah.
Is this supposed to be x minus?
No, it's minus plus. Because you're talking about the factoring. The last term, -2 times 1 is -2. If you had minus minus, it would be plus 2. So your inner term, C, is negative 2x plus 1, gives you the negative 1, okay, like that. Okay, so here's what we're going to end up having on that. That cancels, so the vertical asymptote comes from that one only. So you have a vertical asymptote at x equals 2, so you want to go to your graph and just draw a vertical asymptote only at 2. The one that canceled is not a vertical asymptote. I'll show you what that is here in just a minute, okay? All right, so again, we're going to just go to the calculator. You want to put in the original problem, not the one that we canceled. So we can just kind of change over everything here. And again, parentheses in the numerator. So I'm going to go 3x plus 3, close parentheses, and then the denominator, just put it in as it is. So that is x to the second minus x and minus 2. Okay, like that. And then just graph it, same window. Then we're just going to make a sketch of the graph. So I think I got everything in there good. So it's going to kind of go like this then. All right, so again, the structure of this is it's going to level off there. It's going to level off here and go towards the vertical asymptotes like that. Okay, that's what's going to happen. Now, what I want to do is just get some points. So I'm going to go to my table, learn how to use this table so I can go second graph. And let's just find some good points just so we have a fairly accurate graph. What I see is 1, negative 3, for example. I also see 3, 3. So over 3 up 3. I also see 5, 1. And that's probably good enough. And then the rest of it, you just sketch it. So what we're going to do is just kind of make the sketch like that, doing exactly what the calculator showed us. And it'll go kind of like that. All right, now the other thing is, this doesn't show up on the calculator, but what you have is, if you look at that x plus 1, that gives a whole. So if you solve this equation, you'd get x equals negative 1. So what you want to do is go to where x is negative 1, and you put a little bubble in there, because the function is undefined there, so you got to have a whole. That's what happens. The one that canceled out, you're undefined there, so there's going to be a little bubble there, okay? So let me just kind of summarize what I did on this. Because the degree of the numerator and denominator was less, then that's automatically your asymptote. This is where it's a little tricky, is the one that's left over is your vertical asymptote. So you have x equals 2, and then the one that canceled, it just means when x is negative 1, the graph has a little hole in it. The reason is, there's two things that make the denominator 0. There's 2 and negative 1. That's the asymptote, that's the whole. That's how it works, okay? All right? So that's kind of how that particular graph would go. The next one we're going to do mostly on the calculator also. Does that make sense or not? Okay, the one that's left over is the asymptote, the one that cancels the whole. You'll see that a little bit. If you're going to take calculus, that's actually a fairly important thing. Okay, let's do this one. This is the last rule that I showed you. There's 3 rules. Tell me what the degree of the numerator is. 2. What's the degree of the denominator? 1. Okay, so here's the rule. If the degree of the numerator is greater than the degree of the denominator, then you don't have one. Okay, so there is no horizontal asymptote. You're not going to have one. It'll kind of slant, kind of like a line. So we're not going to do anything on this problem. What we have is the vertical asymptote would occur at x equals negative 1. So we do have a vertical asymptote on this problem. And then we'll put this in the calculator, and I'm just going to have you make a rough sketch. We're not going to do all the details of this problem in this class. You do a little bit more in a college algebra class. So on the calculator, let's just put this in, and it'll look a little different this time. So I'm going to put the numerator in 2x squared, and then plus 6x, and was that a minus 2, and then divide by, and then make sure you have parentheses around the x plus y. So put that in, type graph, and it'll look a little bit different to you this time. And all we're going to do on this is just make kind of a rough graph. Okay, so what we're going to end up having is the graph kind of does this. Around the asymptote, it goes like this, So it's going to kind of do something like that. And what's happening on this one is there's no vertical asymptote, so the graph just sort of does this. It kind of just goes to negative infinity like that, and then it goes to positive infinity like that. So all I'm going to do on this one is just have you get a couple of points. So I'm going to go second graph and just find a few good points just to make a fairly accurate graph. So you can look at what some of these are. Here's -4, -2, for instance, -3, 1, -2, 6. And then you can just kind of sketch that. That does something kind of like that. Here's a point 0, -2. Here's 1, 3. And that's good enough. And then from there, it just kind of does something like that. All right. And on that one, actually, what happens is there's an asymptote that's a line that slants that goes through there. So what will happen is, and I'm not going to teach you how to find that, there's a linear function that goes through like this, and then what happens is this thing just gets close to that asymptote. We call that a slant asymptote. But we don't talk about that in this class. All right, so that would be kind of the idea. All right, so just to kind of summarize what we did, the graphs on this you shouldn't have trouble with because you're going to use your calculator, number one. The key stuff you want to get from your graphs is make sure you know these 3 rules that help you find a horizontal asymptote, and be sure you know how to find a vertical asymptote and a hole. Those are the things you have to do, and then let the calculator kind of take over, okay? All right, now one last thing I'm going to do. I'm going to do this application, and you see this in business. We have what you call an average cost, so I'm going to show you how to do that, and we're going to do something with the graphing calculator on this. So first of all, C of X is just like a total cost function. It's the total of what you're producing. It's the total cost, and this is pretty important. Like if you see C of 10, that doesn't mean how much the 10th item cost. It means how much all 10 of your first items cost. And that will change depending on how many things that you are manufacturing. The average cost we just represent with the bar. So anytime you see C bar, that means you're looking at an average cost, and you have to use this formula to do this. So what the average cost is it's just the total cost divided by the number of items that you're producing. When you divide it by how many items you're producing, you're averaging out the cost of the items you're doing. Okay, so the first thing is on this problem, we're going to do most of this on the graphing calculator, but what you're given on this one is you're manufacturing DVDs, and X is how many DVDs per day that you manufacture, and then this is the daily cost. Okay, now what that is that's a total cost. So if you did C of 100, what that would mean is that would mean the grand cost of producing all 100 DVDs. It wouldn't be the cost of just the 100. Everybody with me there? That's important, okay? So what we do to find the average cost is we do this. So when you find your average cost, you're going to write down the cost function that I gave you, x squared plus 2x plus 2,000, and then you just divide each term by x. Okay, that's what you're doing when you're doing an average. Okay, then you're going to simplify this stuff to put this together. Okay, so basic algebra skills. What's x squared over x? X. Okay, the next one, the x's cross out, so you're left with 2. And then the next one, you're going to have 2,000 over x, just leave it like that. So that would be the average cost function. All you ever do is take the cost function you're given and divide by x. And just be sure you divide each piece by x like that. Okay? All right. So now we're going to do this on our calculator. So we're going to go ahead and graph the function that we just put together. And so you want to get your calculator out and just kind of wipe out what we did on the last problem here. And let me move this over so I can see this okay. All right, so you're just going to put this in, okay? So we're going to put in x plus 2 plus 2,000 and then divide by x like that. And we'll talk about a viewing window to do on this. And what you're going to find on this is it's going to reach some sort of a minimum value on this. Okay, so what we want to do when we start putting together our graph, let's go ahead and start putting together graphs. So go ahead and just get your X and Y axis put together. The X axis is number of DVDs that are produced. Okay, and then this is average cost that we call C bar of X like that. Okay, now on your graph, I've given you that we're only interested in between 5 and 150 DVDs. So what I'm going to do on this is just kind of do this. I'm going to start at 5 like that, and then we're going to go all the way to 150. And you can divide that up however you want to. I'm going to just kind of go like, okay, here's 50, here's 100, and that's good enough, okay? Because we just need to get a couple of points anyway. Okay, so here's what you want to do. When you go to your window button, go ahead and get your X values set up. Now, you can either go to 5 to 150. I would prefer you just go 0 to 150 for your graph, but we're only going to start our graph when X is 5, and then you can scale that probably by like 50. Okay, kind of like that. So that would be a good way to get your X-axis put together, all right? Now you got to figure out the Y. So the way you figure out the Y is just start looking at your table of values to get an idea. So once you've got your graph in the window, then go second graph, and then just start looking at these values. Okay, so see, once we get to X equals 5, if you kind of start looking at these numbers, they're in the hundreds, and it looks like they're getting smaller. You're probably going to find they get smaller and then get bigger. The biggest number I see is like 407. So since I see 407, I'm going to have you do this. For the Y, let's go 0 to 500. And then maybe scale that by 100 like that. Okay, and let's try to graph that and see what we get. And then I'm just going to put a 500 there, and then 1, 2, 3, 4, something like that. Okay, so I look at the table to figure that out. See, now if I type graph, you should have something that looks like it hits a low point, and then it starts picking up again like that. So if you got the window, if you're following on the window, that's what you get. Now, all I would want you to do on a graph is just maybe get 3 points. Okay, that's good enough. I'm going to show you how to find this minimum here in a minute. So what I would do is just trace at a number a little bit bigger than 5. So like if you trace at something like 6, for instance, you're going to get like about 341. So just for estimation purpose, we go over 6 and up about 341, like that. Then probably trace at 150. Go ahead.
What were the scales for? Again?
Okay, like this. Oh, wow. So what I did, the Y, I'm going 0 to 500 by a scale of 100. Okay? Because you got to get that put in order to see, the entire shape. So once you get that put in, you should be good. Okay? Now let's trace at 150. The graph ends at X equals 150, so if you type trace 150, then we'll have another point. This looks like 150 and about 165. So I'm just going to have you label that as 150, 165.3. Okay, like that. Okay, now what we're going to do is we're going to find the minimum. All right, and the way you do this, we've done this before. Write down the keystrokes if you need to. You're going to go second trace. You have to have your graph up to do this. So you start by going second trace. And then you go down to option 3, which is a minimum. So you go to highlight option 3, press enter. Okay, like that. Now it's going to ask for bounds. Okay, so what you want to do is get your cursor will pop up somewhere. You want to move the cursor until it's a little bit to the left of where that minimum is. You got to get it kind of in the right place. So I'm going to go like that. Your guys' calculator is probably faster than mine because these emulators are kind of slow. So we do that, and let's still go. Just wait until you know that you're to the left of that minimum. Okay, right now I'm convinced. Okay, you see what I mean? I know I'm to the left of the minimum. Then I press enter. Then the right bound, press your right cursor key until you're convinced that you're to the right of where that minimum is. Okay, keep going. I still need to go a little bit further. You can go way out if you want to, so I think I'm in pretty good shape now, so I do that. All right, then when it says guess, just press enter, one more time. So if I press enter, then it'll give you that minimum. So that minimum is at the point 44.7 and 91.4. So that will be my third point. I'm just going to estimate about 44 and 91, something like that. And that's good enough. So your graph would kind of do something roughly like that. Okay? So you do those keystrokes to find a minimum. You can also find a maximum. We've gone over how to do that also. All right, did everybody follow what I did there okay? All right? Because you have to do that with your calculator. You can't do that any other way. So if you take this answer that we got, I'm going to just take a quick screenshot of this real quick. On the next page, we use this to answer the next question. Okay, so here's what we have. All right, so we ended up getting this point. This is our minimum right here. All right, so what this means basically is this would be the average cost. The Y value is the average cost. And then this right here would be the number of DVD players. So the daily production level that produces a minimum cost would be about 44.7. You could round that to 45 if you wanted to. It doesn't matter. It looks like they want you to do the daily to the nearest integer. So we'll just say it's about 45 DVDs. The minimum average cost will be about $91.40 per DVD player, or per day. I'm sorry, per day. That's it. Okay, so that's how you put that together. We're going to look in this class at a lot of basic business applications where you do some algebra and you do technology also. That's the idea. Okay, that's called a minimum average cost. Anybody have a question about that? Okay. All right, so that'll wrap up that section. I'm going to go ahead and close this off. We're going to, for the chapter 4 stuff's going to go quicker because we're going to use our technology a lot. In chapter 4, you're going to have to know how to use certain things on your TI, but the first part of this that I'm going to run through today, we probably won't need